Welcome to Brainwaves. In today's episode, we dive into the intriguing topic of flat Earth theory. While the vast majority of people believe that the Earth is a sphere, there is a small yet vocal community that insists the Earth is flat. So, what exactly is flat Earth theory and what are the arguments put forth by its proponents? Let's explore this controversial subject together. We'll examine the basic principles of the flat Earth model, explore some of the common arguments made by flat earthers, discuss the scientific evidence against this theory, and ultimately debunk some of the myths surrounding flat Earth theory. In order to understand the origins of flat Earth theory, we must delve into its historical background. The concept of a flat Earth can be traced back to ancient civilizations such as the Babylonians and Egyptians, who believed in a flat disc-shaped Earth. However, as early as the 6th century BC, ancient Greek philosophers, like Pythagoras and later Aristotle, proposed that the Earth was a sphere based on various observations and logical reasoning. Image source: Ancient Flat Earth Map. Now that we have explored the historical background, let's dive into the basic principles of flat Earth theory. According to flat earthers, the Earth is a flat, disc-shaped plane with the North Pole at the center and the continents spread out in a circular manner towards the edges. They believe that the Earth is covered by a dome-like structure called the firmament, and that the sun, moon, and stars revolve around it. Flat earthers argue that gravity is not the force holding us to the Earth, but rather an upward acceleration. Now let's explore some of the core arguments put forth by flat earthers. One of the main arguments is based on the observation that the horizon appears flat. They argue that if the Earth were truly a sphere, there should be a noticeable curvature. Flat earthers also highlight the lack of visible evidence of Earth's curvature from high altitudes or space, questioning the authenticity of photographs from space agencies. Additionally, they claim that the existence of gravity can be explained by the Earth constantly accelerating upwards, which gives the illusion of gravity. Image source: Curvature of the Earth. In the flat Earth model, the Earth is believed to be a disc-shaped plane rather than a spherical object. According to this theory, the North Pole is situated at the center, and the continents are spread out in a circular manner towards the outer edges. Flat earthers argue that the circumference of the Earth around the equator is much larger than that from the North Pole to Antarctica. They claim that the widely accepted globe representation is inaccurate and that the true Earth is a flat disk. According to flat Earth theory, the Earth is covered by a dome-like structure known as the firmament. This concept is based on ancient biblical interpretations and suggests that there is a solid barrier separating the Earth from the rest of the universe. Flat earthers believe that the firmament acts as a protective cover, preventing the atmosphere and water from escaping into space. They argue that this dome creates a contained environment, similar to a snow globe, with the Earth and its atmosphere enclosed within it. In the flat Earth model, the sun, moon, and stars have a unique configuration. Flat earthers propose that the sun and moon are smaller and closer to the Earth than modern science suggests. According to this theory, the sun moves in a circular path above the disc-shaped Earth, providing light and warmth to different regions at different times. Similarly, the moon is believed to emit its own light rather than reflecting sunlight. As for the stars, flat earthers assert that they are fixed in position and rotate around the North Pole as the center of the Earth. One of the common arguments put forth by flat earthers is the lack of visible curvature on the horizon. They claim that if the Earth were truly a sphere, there should be an observable curvature when looking out at the horizon from an elevated position. Flat earthers argue that no matter how high you go, the horizon appears flat and level. They often cite photographs and videos taken from high altitudes or airplanes, showing a seemingly flat horizon as evidence to support their belief in a flat Earth. Flat earthers often question the authenticity of photographs and videos provided by space agencies, such as NASA. They argue that these images can be easily manipulated or distorted to fit the narrative of a round Earth. Flat earthers claim that the photographs showing a spherical Earth from space are either the result of fish-eye lenses or computer-generated images. They also question why there are no photographs or videos that show a complete view of Earth from space without any visible curvature. Flat earthers put forth alternative explanations for gravity that diverge from mainstream scientific understanding. They propose that gravity is not a universal force pulling objects towards the center of the Earth, but rather an upward acceleration. According to this viewpoint, the Earth is constantly accelerating upwards, which creates a force or equivalent gravity that holds objects down. This alternative explanation challenges the widely accepted concept of gravity as a result of the mass and density of celestial bodies. Flat earthers argue that the observed effects of gravity can be explained by this upward acceleration. Scientific evidence strongly contradicts the claims of flat Earth theory, especially when it comes to the Earth's curvature and the horizon. The curvature of the Earth can be observed in various ways, such as the way ships disappear hull first as they move away and the way buildings on the shoreline gradually disappear from the bottom up. Additionally, from high altitudes or during airplane flights, we can witness the clear curvature of the Earth. Satellite imagery and photographs taken from space also provide undeniable evidence of a spherical Earth. These images show a distinct round shape and the curvature of the Earth's surface. Satellite imagery and space exploration provide compelling scientific evidence against flat Earth theory. Numerous satellites orbiting the Earth capture high-resolution images of our planet from different angles, showing a spherical shape and the curvature of the Earth's surface. Additionally, astronauts aboard the International Space Station have taken photographs and videos that clearly depict a round Earth. Space exploration missions, such as the Apollo moon landings, have provided further evidence of our planet's shape. The images of Earth taken from space are consistent with the globe model and do not align with the claims made by flat earthers. The concept of gravity and its effects provide substantial evidence against flat Earth theory. Gravity is a fundamental force that attracts objects towards each other based on their mass. The laws of gravity have been extensively studied and tested, and they consistently demonstrate the spherical shape of celestial objects, including Earth. Gravity also explains various phenomena, such as the way objects fall towards the center of the Earth, the motion of planets, and the tides caused by the gravitational pull of the Moon. Flat Earth's alternative explanations for gravity fail to account for these well-established scientific principles. One of the prevailing myths surrounding flat Earth theory is the belief that the horizon always appears flat, suggesting a flat Earth. However, this notion is easily debunked by basic observations and scientific knowledge. In reality, the horizon appears flat due to the vast size of the Earth and the limitations of our vision. The curvature of the Earth is not immediately noticeable from ground level, but it becomes apparent when observing objects at a distance. As an object moves away, it gradually disappears from view bottom first, providing clear evidence of the Earth's curvature. Additionally, photographs and videos taken from high altitudes or space clearly show the curvature of the Earth. Flat Earth theory is often associated with conspiracy theories, suggesting that there is a global cover-up by governments and organizations to hide the true nature of our planet. However, this claim lacks substantial evidence and is based on unfounded speculation. The idea that thousands of scientists, engineers, astronauts, and government officials are part of an elaborate conspiracy stretches the bounds of reason. The overwhelming scientific consensus, extensive research, and empirical evidence all support the fact that the Earth is a sphere. It is essential to critically evaluate the sources of information and rely on reputable scientific institutions for accurate knowledge about our world. The scientific consensus and overwhelming body of evidence strongly support the fact that the Earth is a sphere, debunking the claims of flat Earth theory. Scientists from various fields, including geology, astronomy, and physics, have conducted extensive research and experiments that consistently demonstrate the spherical shape of our planet. Measurements of Earth's curvature, satellite imagery, global positioning systems, and space missions all provide compelling evidence of a round Earth. Additionally, the understanding of gravity, the behavior of light, and the navigation systems we rely on are all based on the scientific understanding of a spherical Earth. It is crucial to trust in the rigor of scientific methods and the consensus of experts when evaluating claims about the shape of our world. And that concludes our exploration of flat Earth theory. While it may be an interesting concept to ponder, the overwhelming evidence from scientific research, satellite imagery, and numerous experiments conducted over centuries supports the fact that the Earth is indeed a sphere. The theories and arguments put forth by flat earthers often lack empirical evidence and fail to stand up to scrutiny. It's important to approach such topics with an open mind but also critical thinking. As we continue to delve into scientific discoveries and explore the wonders of our world, let us embrace knowledge and evidence-based reasoning. Thank you for joining us on this fascinating journey.